Hello students, welcome back. So now I'm going to be talking about confusion matrix. Suppose you have following 16 labeled data, this one right here, that you feed to a machine learning model. So in this case, you have feature 1, feature 2, and an actual target. Your feature 1 could be height of somebody, feature 2 could be weight. Actual target, maybe it could be whether he can play basketball, maybe whether he has some type of physical problem or not. These are your targets. So in this case, 0 could mean one thing, 1 could mean opposite of that. So you feed your feature 1 and feature 2 to your machine learning model. This one right here. This could be any regression model. This could be any model. Okay. This could be random forest, decision tree, any you pick any one model. So this model makes a prediction. So it has some predicted target right here. Let's say it makes a prediction 0, 0, 1, 0, 1 for all these features right here. Now you also know the actual value. You also know the actual target. So you can compare the actual target with the predicted target. And by comparing, you can determine how many of it got it right and how many of it got it wrong. Well, this one it got it right, but this one it got wrong. And the reason it got wrong is because this one actually is 1, but you can see that it should be 0. So this it got it wrong. And likewise, right, this one it got it wrong, right, wrong, wrong. So all the red ones it got it wrong, rest of them it got it right. In other words, if you count, you will have total of 4 misclassified targets. One, two, three, four. So let's create a matrix that would show how many were classified correctly and how many were classified incorrectly. So this is a matrix I created. So this one actually is my actual label right here. And this one would be my predicted label. So in this case, this right here is 0 and this 0. This refers to the actual label was 0 and the predicted was 0. And let's find out how many were actual 0 and predicted were 0. Well, if you count over here, your actual 0, predicted 0, that would be 1, actual 0, predicted 0, that will be 2, and then this would be 3, and then let's come down over here, this would be 4 right here, and then actual 0 and predicted 0, this would be 1, 2, 3, 4, 5, and this would be 6. So there are a total of 6 of them, and this is how I get this 6. Let's look at this number. This is telling you that the number, they were actual 0 and how many were predicted 1. So let's find out how many were actual 0 and they were predicted as 1. Well, let's see. This one would be 1 right here. So that would be 1. Okay. Actual 0, predicted 1. That will be 2. Let's come down. That's it. It's only 2. So this is how you get this number 2. And same thing with this one and same thing with this one. Okay. So the on diagonal elements, the ones on these ones right here, they represents the correct ones because the actual was 0 and the predicted is 0, so that would be your 6. These are your diagonal ones. This one right is 6, that represents, oh, let me just remove everything so it's a little bit more clear. This one right here, that represents the number that was actually 1 and that was predicted as 1. So this is a good one. So the diagonal ones are the good ones. They are the ones that were classified correctly. The off diagonal ones, the elements that are not on the diagonal, that would be this one and this one, these were misclassified. So this matrix is called a confusion matrix. So the confusion matrix, it tells you how many were correctly classified. So there are two types, true negative and true positive, and how many were incorrectly classified. That will be false negative and false positive. So in this particular instance, this one right here, that's my true negative because this is negative, 0, let's say is negative, and this was also negative. This was also 0. So the true negative is 6 right here. So this is called true negative. Likewise, this is called true positive. So this is my positive right here. 1 is a positive, and this is is positive. So in this case, this is called true positive. Likewise, this is called false positive. Actually, this was this was showing actually a positive. Sorry, this was actually a negative because this is 0, but it showed 1. It shows positive. So this is called false positive. Now, instead of working with the raw numbers, if you want to see the percentage, that's easy too. All you have to do is divide every single element by the total records. So in this particular case, you divide by 16 because I have total 16 records. So 6 divided by 16, 37.5%. 2 divided by 16, 12.5%. Likewise, 37.5% and 12.5%. So the diagonal ones is 37.5%. This one It got it 37.5%. So 37.5 plus 37.5, whatever your answer is, that's the one. That's the total percentage it got it right. This 12.5% plus this 12.5%, that's the number of percentage it got it wrong. So confusion matrix is not just about the accuracy, it is also about understanding errors. Now you can calculate confusion matrix very easy from scikit-learn. So in this case, you can import this confusion matrix. You can import confusion matrix display. This is for displaying the numbers. So let's say my y actual, these are my y actual 0, 0, 0, 0, these numbers, and this is my y predicted. And you can see that this one is wrong. Okay, it got, this is a mismatch right here. This is a mismatch. So you can see there are a few mismatches. This is exactly same as the previous one. So in this case, all you have to do is just call the confusion matrix and you supply your y actual and supply your y predicted. And then you print out your confusion matrix. And this is your number. This is exactly the same number I just showed you. If you want in percentage, you can do that too. So just call the same function confusion matrix, supply your y actual, give your y predicted, and in this case, you specify this parameter normalize equal to all. And when you print it out, it's going to give you the percentage in fraction, by the way. So this is 37.5%, 37.5%, 12.5, and 12.5%. Now, if you want to display this through a heat map, you can do that too. All you have to do is just call this confusion matrix display, supply your confusion matrix to this, and then you call your plot inbuilt method, call your title. In this case, you specify a title, and then you just do plot show right here, render the graph. So you can see that your diagonal ones, this is 6 right here, this is 6 right here, and this is 2, and this is 2 right here. So by looking at this, you can see like, these ones, these are your two numbers right here, this color, and this color would be your number 6 right here. So you can also use confusion matrix for more than two classes. So let's maybe you can have 3, 4, 5. You can have these many number of classes. So let's say this is a confusion matrix of 4 classes. So in this case, I have y actual. These are the classes 0, 0, 0, 1, 1, 1, 2, 2, 2, and 3, 3, 3. So these are, you can see there are total 4 classes over here. Uh, in this particular instance, this is my prediction, and you can see that some of them, this one it got it wrong, then some of them it got it right, some of them it got it wrong. Like this is wrong. Yeah, this is wrong. Wrong, wrong. Okay. So in this case, supply your y actual, supply your y predicted value to your confusion matrix, and print out your confusion matrix. So this is my confusion matrix right here. So let's understand what's happening over here. So this is my predicted side right here. Okay, and this is my actual side over here. So my predicted class, this would be class 0, this would be class 1, this would be class 2, this would be class 3. For my actual, this would be class 0, 1, 2, 3. Okay, let's look at one of these numbers. Let's pick up this number right here. What this is telling me, that there are two records. There are two labels that was actually three, but they were misclassified or they were predicted as zero. So there were two of them. There was actually three, but they were classified or they were predicted as zero. Let's find those one out. Actually three. Actually three are these ones, right? And they were predicted as zero. Ah, these ones right here. You see that? That would be one, and that would be two right here. So these are the two values. This is how you get two.